Welcome. Let's take a look at some more examples when we have dependent events. So number 2, a university class has 27 students, 13 are accounting majors, 8 are psychology majors, and 6 are business majors. The professor is planning to select 2 of the students for a demonstration. The first student will be selected at random, and then the second student will be selected at random from the remaining students. So this is another way to say sample 2 students without replacement. So let's take a look at A. Find the probability of selecting an accounting major followed by a business major. So let me write the question here. We want the probability of, we'll just do A for accounting, and then B for a business major. All right, so our formula for the multiplication rule, we take the probability of an accounting major times the probability of a business major, knowing that, given that we picked the first student that was the accounting major. So I'm going to go ahead and use my table here to organize the information. So when we first start, 13 accounting, 8 psychology, 6 business for 27 total students. And we're going to start with wanting an accounting major first. So 13 out of the 27 be our probability of getting an accounting major. All right, so after we pick the accounting major, they are no longer available. So we're going to pick from the remaining students. So we would no longer have 13 accounting majors. There would only be 12 left. We'd still have 8 psychology, 6 business. We wouldn't have 27 students remaining. We just have 26. So now I'd like to find the probability of getting a business student. So we would have 6 out of those 26. So you can use a table or not to help you be organized there. And I'm just going to enter it on the calculator like I speak it. 13 out of 27 times 6 out of 26. And the directions say to round to 3 places. So that would be 0.111. Just leave that in decimal. All right, one more here. Let's do the probability that both students are accounting majors. So an accounting major and another accounting major. And for the next problem or so, I'll write the formula and then we'll just go straight to the substitution. So it would be the probability of an accounting major times the probability of a accounting major second, given that the first student was an accounting major. All right, so first round, we have 13, 8, 6 for a total of 27 students. An accounting major, 13 out of the 27. And then once I select the accounting major, again, we'd be down to just 12 left. We still have 8 psychology, 6 business, but we'd no longer have 27 students. There would only be 26 remaining. So the chances of getting another accounting major would be 12 out of those 26. All right. And then you can enter it and check that answer. And hopefully we get 0.222. All right, so in the next question, we'll extend this to choosing more than just 2. In this case, it'll be people. And let's see how this looks. So number 3. A university's leadership council is made up of 14 members. They have 5 students, 5 teachers, and 4 deans. A newspaper reporter is planning to select 3 of the council members at random for interviews. What is the probability the first member selected is a dean and the next 2 members are teachers? All right, let's write the question here. So now we want the probability that they pick the first member is a dean. Let's do D for dean. So a dean first, and then the next 2 are teachers. So then the second one they pick is a teacher, and the next one they pick is a teacher. So the selections are done without replacement, and then hopefully that's just clear from the context of the question. So if they're going to be the reporters interviewing people, they're not going to interview the same person 3 times. So after we pick a person, a dean, then they will no longer be in the mix of possibilities as we move on to select the next person. So let's go ahead and write the formula. Now, it's going to look a little bit strange when we have 3 in a row. So we'll get to the substitutions in a second. So here's what we would say. We would want to know the probability of getting a dean first, times the probability of getting a teacher, given that the first person was a dean. And then we would say probability the third person is a teacher, given that we picked a dean first and a teacher second. Now, that formula can actually make these problems look harder than they need to be. So I'm writing that one, and then in the next one, we'll go straight to the substitutions. So don't get too concerned if this starts to look a little complicated. So let's just organize ourselves, and hopefully you'll see it's not so bad. So let me put the starting, we have 5 students, 5 teachers, 4 deans, and adding that gave us our 14 members of the Leadership Council. And the reporter on the first pick, we want to know the probability of getting a dean. So 4 out of the 14. All right, so we've got our dean. And then after we pick a dean, we would still have 5 students and 5 teachers. But after we pick a dean, there wouldn't be 4 anymore. There would only be 3. And after we pick that dean, there would be no longer 14 people, but we'd be down to 13. And now they're ready to pick the second person to interview, and we want the probability that we pick a teacher. So 5 out of those 13 are teachers. So we got our 5 out of 13, and then we're ready for our third pick. So on the third round, we still have 5 students. We just picked a teacher, so 4 teachers left. We still have 3 deans there, and instead of 13 people, we'd be down to 12. So the probability that third choice is a teacher would be 4 out of those 12. All right, and then as usual here, I'll just enter it like I speak it. 4 out of 14 times 5 out of 13 times 4 out of 12. And 3 decimal places there would be 0.037. All right, so in the last example, I'm not going to make a table. If a table helps you, then certainly make it. So I know some students find the table helpful, and others can just write down the substitutions here without it. So you'll do whatever works best for you. But let's take a look at this question. So we have an internet research company surveyed 85 online shoppers, each of whom made 1 purchase today. And the company recorded the type of purchase each shopper made. And here is our summary. All right, so first, I want to figure out in total there how many shoppers there are. So if we add the number of shoppers for each type of purchase there, that will be 85. The bottom here, I'm just going to write N is 85 total. And then we'll pick a shopper at random, actually 3 shoppers at random, 1 at a time without replacement. And we'll find the probability that the first 2 shoppers purchased clothing and the third purchased toys. All right, so what I'm going to do here, just for shorthand, is write clothing, toys, and then just do the substitutions. So the probability that the first person I picked bought clothing, 34 out of 85. And then they're out of the mix. So we pick a person that bought clothing. So when I'm ready to pick the second person, there would no longer be 34 that bought clothing. We'd be down to 33. And instead of 85 people, we would be down to 84. All right, so now I've picked 2 people. One bought clothing, the next bought clothing. And now I want my third person to have purchased toys. So we'd still have 16 that purchased toys, but we wouldn't have 84 people anymore. We would be down to 83. All right, and you're welcome to type that in and check it out. That will be 0.030, but we'll try to move forward here and focus on the setup. All right, so B. The first shopper purchased toys, the second purchased clothing, the third purchased electronics. So now I'm looking for toys first, clothing next, followed by electronics. All right, so we start at the beginning here, toy, 16 out of 85. And then we pick that person there out of the mix. So sometimes I do my denominator next. There would only be 84 people left. And we already took away one that bought toys, and now I want the probability of clothing. So I'd still have those 34 people that bought clothing. And then after we pick them, they are gone. So we're down to 83 people. All right, so we took away a toy person, a clothing person, and now electronics. There would still be those 12. All right, and again, if you want to enter that and check it yourself, that will be 0.011. And then the last question here, the first shopper purchased pet supplies and the other 2 did not. So now I want pet supply, and then I'll do my notation for complement, not pet supply there. But now let me go ahead and keep track of some totals here. So I know that pet supply people, 23 people bought pet supplies. So I'm going to need the number that did not buy pet supplies. So that would be 85 people minus those 23. Or you could add 12 plus 34 plus 16. Either way, you would get the other 62 people. Okay, so the probability the first person that we pick bought pet supplies would be 23 out of those 85 people. So we pick that person, so they're gone. So I wouldn't have 23 people left that bought pet supplies. Now there would only be 22 out of the remaining 84. And then for my third pick, I'd be down to 83 people. And the chance they didn't buy pet supplies. So I would still have 62 people there that didn't buy pet supplies. And then again, you can check it. It should be 0.147. All right. So this is a case where sometimes writing, like I did here, writing the formula makes it more confusing looking than it actually needs to be. So you can just go right to the substitutions. And again, if you found it hard to follow without a table like I created up here, you could just go ahead and create a table yourself and keep track of your remaining people every time you make a selection.